Hello everyone, welcome to Pre-Calc Lesson 3.8, More Polynomial Theorems. Basically we're going to pick up on day 7 right here. Let's jump into a couple examples. The directions say list the possible roots and find all the roots and then sketch a graph. So remember what we said yesterday, all the possible roots that we know of right now come from the products of our constant term, which is 6. So to list those, I'm going to write down possible roots plus or minus any factor of 6. 1, 2, 3, 6. So what I'm going to do now is I'm just going to start guessing some numbers and try it in synthetic division. I like to pick 1 or -1 usually because they're the smallest and it's the easiest to calculate. So my coefficients will be 6, -25, 23, and -6. So let's try it. Bring down, multiply, add, multiply, add, multiply, add. Doesn't work. It's not 0, so that means 1 is not a root. Okay, normally I would just cross that off and keep going. I don't expect you guys to erase, but so now let me just randomly guess 3. See if that works. You got 6, -25, 23, -6. Bring down, multiply, add, multiply, add, multiply, add. So I got it. That's a 0, which means this is a root. All right, so let's write that down. X equals 3 is one root. We started with a cubic, and I depressed it 1 degree, so I have a quadratic. The quadratic that's left is 6x squared minus 7x plus 2. That's what's left. All right, so I need to factor that. 6x squared minus 7x plus 2. Let's set it equal to 0 to find those other two roots. Well, this one's not real easy to factor. I'm going to guess 3x and 2x. Again, I don't know for sure. I do know that my signs are the same, and they're both going to be negative, so that helps, makes it a little bit easier. And 2 and 1 are the numbers I'm going to put here and here. I need to get a 7, so that guess actually looked pretty good. There's a 4x, -4x rather. There's a -3x, so that's going to give me a -7. So 2 here, 1 here, and now my two roots from those factors, x equals, here's the shortcut, the opposite of this number divided by that number. So we have a positive 2/3. And over here, x equals positive 1/2. So there are my 3 roots. All right, so now I would like you to sketch this. I've got my 3 roots. My y-intercept is going to be -6. That's easy to get, remember. You just set all your x's equal to 0. All that stuff is 0, goes away. There's my y-intercept, -6. And your tails, let's go back up. Sorry for all the scrolling, but again, we're going to see a lot of cubics. Positive cubic, it's going to look like this, so my tails are opposite. Tails, like so. And let's just sketch a graph. I don't have a lot of room. So I have 3. 1, 2, 3. That's a root. I've got 1/2, so it's going to be about there. And I've got 2/3, which is going to be about there. So I probably should have spread those out a little bit more. And I've got a y-intercept of -6. So it's going to come up through, just above, down, and then back up. So there's a good sketch of P of x. All right, let's try one more. So in this one here, let's list our possible roots. It's going to be plus or minus all the factors of 3. Well, that's pretty easy, 1 and 3. Now I'm going to guess 1 here. And the reason I know 1 is a root is because of a former student, David Lytle, came up with this pretty simple observation. If you look at all the coefficients, so 1, -1, negative 3, and positive 3. If all of those add to 0, then 1 is always a root. So that's the first thing I always check. I add the coefficients. 1 minus 1, 0. Negative 3 plus 3, all that equals 0. So I know x equals 1 is indeed a root. That's the first time we're going to check in synthetic division. 1. I got 1, negative 3, and 3. Bring down, multiply, add. Multiply, add, multiply, add. So there's that root. I knew it going in. But we still have to do the synthetic division because I need the depressed polynomial. So I started with a cubic. I depressed it 1 degree. This is now a quadratic. It's 1x squared plus 0x minus 3. X squared minus 3, basically. Set that equal to 0 and solve. But what do we do if we get a quadratic that does not factor? We have to use other methods. We could do quadratic formula. You could complete the square. This one's pretty easy. I'm just going to do square root method. I'll add 3 to both sides. I get x squared equals 3. I'm going to square root it. Don't forget your plus or minus. Plus or minus square root 3. All right, so those are my other two roots. And let's see, what do we know? Y-intercept. Let's get the rest of information here. Y-intercept, y equals, I'm going to look here. That's going to be a 3. Y-intercept is 3, and my tails against positive cubic. We see a lot of these. It's going to look like that. Let's make a sketch. So I've got 1. That's a root. And square root of 3, we just have to estimate here. If this is calc inactive, we can still do this. Square root 3 is approximately 1.7, so it's going to be a little bit more than that. You can just put a tick mark here and call that square root 3, call that a 1, and then over here do negative square root 3. That's fine. So my graph's going to go through those 3 points. The y-intercept we said was 3. I'm just going to put a mark up there, call that 3. And here are my tails. So it goes up through, turns around, passes through. All of those are single roots, so it just passes right through. Okay, now what I want you to notice, we had some different types of roots here, didn't we? Plus or minus square root 3, those are not rational roots. Those are irrational. That's why they don't show up here. Notice these. Those are rational, but they're not integral. That's why they didn't show up here, because these are just my integral roots, my integers. So where do these come from? Well, in this particular problem, you notice here we had a leading coefficient other than 1. It was a 6. So it turns out we have what's called a rational root theorem that we're going to add to our integral root theorem. The rational root theorem says, given p of x equal ax to the n plus bx to the n minus 1 plus ... plus c. The only possible rational roots are plus or minus factors of c, which we said before for our integer roots, divided by factors of a. So now we have to also think about integer roots and rational roots. Okay. List all the possible rational roots for each polynomial. You're going to see these exact directions on the exam. Notice it does not say find all the roots. It just says list the possible roots. List. You don't have to do any synthetic division here. So how do we do it? Possible roots. First thing I like to do is just list all the factors. Factors of 5, well, 1 and 5. Divided by factors of our leading coefficient, 4. Well, that's 1, 2, and 4. This isn't acceptable. All right, that's kind of like the rough draft, the sketch. I want to actually list the roots. So I'm going to have plus or minus 1, comma, 5, comma. Now we create fractions. Well, we already did 1 over 1, and we already did 5 over 1. Now I'm going to do 1 over 2, 1 over 4, 5 over 2, and 5 over 4. And that's where these others come from. 1/2, 1/4, 5 halves, and 5/4. These are all the possible rational roots. All right, how about our next one over here? Possible roots. Plus or minus, let's get the rough draft. Factors of 2, 1 and 2, divided by factors of our leading coefficient, 1 and 3. Well, that's not too bad. It's going to be plus or minus 1, 2. There's our integer roots. And now I create the fractions. Again, you've already done 1 over 1, and you've already done 2 over 1. So I have 1 over 3 and 2 over 3. So those are the only ones I need to add. 1/3, 2/3. I just had to list those. That's it. So now let's try some longer problems. It says use all your theorems thus far to find all the roots for the following. Now, it doesn't specifically say to list the roots, so in these examples, I'll allow you just to kind of create those general fractions. What I mean by that is this. Possible roots, plus or minus. List all the factors of 3, 1 and 3, over all the factors of 8. 1, 2, 4, 8. So here are the numbers I would try in synthetic division. Plus or minus 1, plus or minus 3, plus or minus 1/2, or 1/4, or 1/8, or 3 halves, or 3/4, or 3/8. Now you can use fractions in synthetic division. It works exactly the same way. You might not be too keen on that because you have to multiply through by fraction every time, but it's actually not too bad. But let's talk about that one theorem I discussed by adding the coefficients. I've got 8 minus 18. So if I combine those, that gives me a negative 10. Plus 7, well, now I'm at a negative 3. Plus 3. So if I add all of these coefficients, that's going to be 0. That means I know x equals 1 is a root. So that's the first thing I would test. That's usually the fastest. Okay, so let's do that. 1, and now my coefficients are 8, negative 18, 7, and 3. Bring down, multiply, add, multiply, add, multiply, add. That's exactly what I was hoping for. So I know x equals 1 is a root. So now, again, because I started with a cubic and I depressed it 1 degree, this is now a quadratic. It's 8x squared minus 10x minus 3. There it is. Now what I need to do is I need to factor that, hopefully. If not, it's going to be a little bit more work. I have to do quadratic formula, complete the square to find the other roots. So this will give me 8x squared minus 10x minus 3 equals 0. And let's see how we're going to factor this. I know it's got to be 1 and 3, so I might actually start there. Let's just try 4x and 2x. Signs are going to be different, so I just have to kind of play around here. That gives me a 2x. That gives me a 12x. You need a negative 10, so this 12's got to be negative, which means my negative goes there, positive goes there. So I get 2 more roots. X equals negative 1/4, and x equals positive 3/2. The direction said, find all the roots. We don't have to sketch it, we just had to find the roots. But this should make sense because notice, negative 1/4. Well, here's how you get it. Negative 1/4. It fits in with that possible root theorem. This one is 3/2. 3/2. It's right there. If you got a fraction that was like 5/7, you did something wrong because 5/7 cannot be created with these factors up above. Okay, last one. Possible roots. Plus or minus factors of 5, 1 and 5 over factors of 12. Wow, 1, 2, 3, 4, 6, and 12. All those are the factors of 12. What do you want to try first? Well, let's add these up. 12 minus 7 is 5. 5 minus 14 is negative 9 plus 5. So that does not equal 0. So basically, you know that's not a root. I'm not going to try a 1. All right, so usually what I would do next is I would go to negative 1. I like to try the smaller numbers first. Coefficients, I've got a 12, a negative 7, a negative 14, and a 5. Bring down, multiply, add, multiply, add, multiply, add. Excellent. First guess worked. That's a 0. That's what I want. So I know right now x equals negative 1 is a root. So now, this is a depressed polynomial. It's going to be 12x squared minus 19x plus 5. That's what's left. That's what I need to factor. 12x squared minus 19x plus 5. Set that equal to 0 and factor it. This one's going to be challenging. So what I noticed first here, I don't want to mess with that. There's a lot of options. Not so many here, right? 5. There's only 2 factors, 1 and 5. Signs are the same, both negative. So you know going in, I'm going to have a negative 1 and a negative 5. So now I can just kind of play around with the 12x squared. Is it going to be 3x and 4x? I don't know. Let's see. That gives me negative 15x. That gives me negative 4x. Wow, kind of got lucky there. That does work. So it's going to be 3x minus 1 and 4x minus 5. So my other two roots, x equals positive 1/3 and x equals positive 5/4. So here are your 3 roots, which again should make sense, right? Negative 1, obviously, here's negative 1. Done. 1/3, does that make sense? Yeah, because look, it's right here. And then how about 5/4? Right here. So again, if you get a fraction that's like 7/3, you know you've done something wrong because you can't get 7/3 from those factors. That wraps up day 8. I know it's been a long couple days here with all this synthetic division, all of our theorems, but I appreciate you guys following along. You now have more than enough information to go ahead and do homework 7 and 8. As usual, guys, reach out if you have any questions, and we'll see you soon.